So good morning. In today's session, we have to study about the DC machine. Here we are supposed to see how we can use DC machine as DC motor and the DC generator. So here, when we will need the DC machine, which we can supposed to use as the DC motor. At that time, we can take armature winding that will always be working as a rotor in the DC machines. But what we are saying, when we are supposed to use the DC machines that will use the electrical energy and that will give us mechanical energy, that time we can keep field winding that will be on the stator. So here, when we will give the power supply, that DC current will pass through the field winding. And this current will supply either from the armature winding or from any other source, because here we are supposed to use the electrical energy. So we can give source that will be battery also. So here when we are giving the power supply, at that time electrical power should be supplied to the armature winding, and when we will give the power supply, at that time that there will be generation of power. So the mechanical power produced by the motor can be taken to the mechanical load, because here we are supposed to convert that energy into a mechanical. So we can use that power to drive the mechanical load. Like, you can take any example, we can use power supply to rotate the wheels of electrical car. So here, when we are giving the power supply, at that time there will be the generation of mechanical power and it will be taken to drive the mechanical load, and the speed of shaft will be directly proportional to the given voltage. And here we are saying we are taking the field winding that will be on the stator. So here we can say torque is directly proportional to the armature current, but it will inversely proportional to the field current. It will increases only with the increase in the armature current. And how we can increase the armature current? If we are giving the supply voltage, that is nothing but that voltage is directly given to the armature. So here we can increase the value of armature voltage. When we will increase the value of armature voltage, we will get increase in the torque. So here, when we are supposed to use DC machine as a generator, at that time, instead of direct power supply, we can give power supply through the field winding. A DC current will pass to the armature winding through the field winding, and this current can be supplied by separately excited. It means what? You can give external power supply to the field winding and to the armature winding, or you can give your power supply to the armature winding. It will generate the supply, because when we are using the DC machine as a generator, it will create the EMF, it will generate the EMF, and that EMF can be used by the field winding. So here we can say we can give voltage from the armature winding itself. We can say this type of machine as a self-excited. Or we can give externally power supply to the field winding and to the armature winding. So at that time, the mechanical power which we are giving the power supply, at that time mechanical power will supply to the shaft of generator and it will start to rotate by external mechanical power such as steam turbine or second order motor that we can connect to the same shaft, because here we are connecting these parts to the rotor. So this will also rotate, and the generated electrical power will be available from the armature terminal of generator. So here we can say our given voltage, when we will give at that time, mechanical power will generate, and just because of this reason the shaft will start to rotate. So here we can say that generated voltage will directly proportional to the speed of shaft, and it will also directly proportional to the field current. But when we are using DC machine as a DC motor, at that time we have seen speed is inversely proportional to the field current, because here we are putting field winding that will be we are putting on the stator. Galaxy, please mute yourself. Okay. So here, when we are using DC machine as a generator, at that time, we can see here the value of generated voltage will be proportional directly with respect to the field current, and also it will depend on the speed of shaft, how it will rotate. So here we can say electrical motor cannot be considered as passive electrical load, because in passive electrical load we can use only the passive component. Passive means resistor, inductor, capacitor, which will not amplify the current. But if you see diode, transistor, at that time, this will amplify. So we can say electrical motor cannot be considered as passive electrical load, because in passive load, the current passing through the load will be proportional to the supply voltage according to the Ohm's law. V equal to IR, because it will not give the amplification in that voltage. Amplification in the current means ये energy sources में amplification नहीं देता है. That's why join. Sameer, mute yourself. You guys are supposed to join class on timer. So here, this is not the case for the electrical machine. The armature current and the armature voltage of the electrical motor are completely independent, because when we are using the electrical machine, at that time we can say the armature current is we can determine by the mechanical torque, because we are aware about the speed characteristics for the DC machine. At that time we have seen torque is directly proportional to the armature current, and the magnetic flux tau is proportional with phi a, tau equal to k phi k into phi into ia. We have seen this concept. So what we are saying here, the armature current we can determine by the torque, which is not related to the given voltage which we are giving to the armature winding. So the same reason we can say about the DC generator. For DC generator also we are supposed to generate the EMF. So the current drawn from the armature is independent of the armature voltage. But what we are saying in the electrical load, we are saying here voltage is proportional with the load, because according to Ohm's law we are taking IR, and Z is nothing but this is the impedance. Impedance means the impedance of load. But when we are supposed to use DC machine or the DC generator, at that time we are saying the value of current is independent on the voltage. So here, to increase the output current, we can say we can increase the output power also. Should be compensated by increasing the mechanical torque. That is nothing but the input torque. So here we have seen about the power. Power is nothing but it will depend only on the armature current and armature voltage, because what we are saying that mechanical power will not depend on the given input voltage. It will depend on the armature winding voltage and current when it will rotate at that time. How much current will flow through that, it will depend on that only. We are saying here for generating mode also the current from the armature winding is independent of the armature voltage. But here electrical में क्या होता है, it is depending on that current. So we are saying we cannot use here electrical machine. At that time when we are using the DC power, DC machines, that will be DC generator or that will be the DC motor. At that time that electrical power which is flowing into the motor, or the electrical power which is going out of the motor, that can be calculated as multiplication of voltage of armature winding and current flowing through the armature winding, because P equal to V into I. So you can take V armature into I armature. But we are aware about the mechanical power which will related with the angular velocity and torque, because when motor will rotate at that time, it will depend on the speed of that shaft. I have just told you. Mechanic. Here, what we are saying, the torque produced will be directly proportional to the armature current. And again, we are saying here, when we are using the value DC machine as a DC generator, at that time also, here voltage is proportional to the speed. This is nothing but the rotational speed. We can take as a W, angular velocity. So we can take here mechanical power equal to torque into W shaft. It is nothing but angular velocity of shaft. This is the speed. So we can say the mechanical power flowing out of the DC motor, or the mechanical power which is flowing into the DC generator. We can take it is the multiplication of angular speed of shaft, and we can take multiplication of the shaft torque. And we are using the unit for torque is nothing but Newton meter. So we can calculate power which will have unit watt, P equal to torque into W. But the speed of machine we can calculate in the rotation per minute. When we are denoting by capital N, speed in the DC machine, that will be in DC generator or DC motor. At that time, we can take that is as a capital N. But when we are supposed to label small n, that is nothing but when we are measuring the angular speed. At that time, you are supposed to take that speed in the radian per second. That's why we are using W. Actually, W का formula होता है 2 pi upon T. 2 pi into N. You can take 2 pi upon T, or you can take 2 pi N. That is nothing but the capital N. But what we are saying, when we are supposed to measure the angular speed of shaft, that time it will require in the second. But we are having the speed in the rotation per minute. That's why we can convert into a second. So W equal to 2 pi N upon 60. So here, what we are saying about the efficiency of machine, if it will give higher output as compared to the input, what we can say, yes, it is more efficient. If we are taking anything at a home, if we are using, it is working very properly, at that time हम क्या बोलते हैं, yeah, it is the efficient. Like this, when we are using the DC motor, at that time what we require output power as the mechanical, and we are giving input as a electrical. So it will be the ratio of output power with respect to input power, and here we are having the output power, this is the mechanical, and we are giving the input power, this is nothing but the electrical energy. So for DC motor, neta, this is the symbol for the efficiency, equal to P mechanical upon P electrical. And when we are using DC machine as a DC generator, at that time, that efficiency we can define as it is the ratio of output electrical power with respect to input mechanical power. Because when we are using the DC generator, हम क्या कर रहे हैं, mechanical को electrical में convert कर रहे हैं. So we can take neta equal to P electrical upon P mechanical. We are only revising these equations because these equations you guys will require to solve numericals. जैसे you will require equation for DC shunt motor when we will give the supply. At that time, you will get that voltage will be equal to EB plus IARA, because armature current वहाँ पे when you will connect the DC machine, at that time there will be some amount of impedance, resistance RA, and there will be some current will flow through that. And again we are using the back EMF concept for the DC motor, and we are using the DC generator के लिए generated EMF. So that voltage which will be across that armature will be equal to क्या होगा, EB plus IARA, V equal to, or you can take E equal to. Again we will require EB equal to NP5 upon 60. into Z by A. These equations you will require. Again, mechanical power equal to torque into omega, angular velocity. Sometimes they will not give directly value. So they will give the value of speed. You can solve here. Pi, you can take 22/7 or you can take 3.14. You will get the value for the angular speed. So again, what we are saying here, when we are using the DC machine, at that time, efficiency of DC machine will vary with operating condition. These are nothing but its speed, its voltage, and the value of efficiency we can calculate it for speed, for torque, voltage, or current. Again, we can see if we are supposed to find the total net torque at that time, what we are saying, when we are giving the value of power supply at that time, their torque will produce. So that torque will be divided, some to the load and some will give to the armature. So you can take tow motor equal to tow net plus tow load. T को मैं tow बोल रही हूँ because we are calling torque, and this torque we are denoting by tow letter, or we can write by the T, but इसका pronunciation होता है toe. That's why I'm calling here. Okay. So what we can say here, when we are supposed to find the net toe at that time, what we are saying, when we are using the DC machine, or that will be the DC motor, DC generator, and when we will give the power supply at that time, some torque will go to the load and some will go to the motor. So you can take total tow motor equal to tow net plus tow load. So here you can convert, rearrange that equation to calculate the value for tow net. I have given here what terms we are using here. J is nothing but it is the total inertia. Inertia means what? When it will rotate. What we are saying, when we will give the power supply at that time, we are using the DC machine which is having some part as a rotor. So this will rotate like armature winding. At that time, J is nothing but its total inertia of the rotating parts. Rotating part means here we are using the rotor, here we are using shaft, load. W is angular speed. So we can take angular speed. So d omega by dt is nothing but, if we are taking is the speed. So derivative of speed with respect to time we can call as a acceleration. So we can say d omega by dt will give acceleration of that motor. If T motor will greater than T load at that time, we can say motor is accelerating because it will increase the speed. And if T motor is less than T load, मतलब load के comparison में if our motor is taking lower torque, it's generating lower torque, obviously it will go to the deaccelerating. So we can say that motor will decreases its speed. So here I have drawn the graph for magnification curve of the DC machine. The magnetization curve for DC machine shows the relation between armature current, and armature current is nothing but we are saying here when we are supposed to see about the armature current. At that time, it will depend on the voltage. That is nothing but produced voltage. When we are using the DC machine as a DC generator, at that time we can call that as a generated EMF or a armature EMF. So here connect करते हैं, disconnect होते हैं. Okay. So here when we are supposed to study about the magnetization curve of the DC machines, at that time we can say the magnetization curve is nothing but it is the relationship between armature EMF, means what? The curve, armature voltage, induced EMF, and it is the relation with field current. So due to the magnetic properties of current, core magnetization characteristics will look like a hysteresis loop. This symbol we are saying as a hysteresis. These concepts, this diagram will not required. Only you are supposed to study about how the value of field current and value of armature current is related with each other. Because in your syllabus there will be question on numericals and there will be question on the construction characteristics for DC motor, that will be self excited, that will be separately excited, that will be DC shunt motor. Again there will be question on series motor, which we have seen by using the DC machine, that will be same for DC motor or the DC generator. There will be question on the construction of DC motor. So ये ड्रॉ करने का जरूरत नहीं है, but this concept you will require how the value of EMF will related with the field current. So here we can say the magnetization curve is often shown as a single curve, which will give us how the value of EMF, generated EMF, is in proportion with the field current. So here, what we are saying, this is the complete magnetization curve, and if you see here on y-axis, we are taking the value of EMF, and y-axis, we are taking the EMF. On x-axis, we are taking the field current. So here, if you see the magnetization curve for two different speed, if we are changing the speed, at that time you can say here value of EMF will increases with value of field current, because here we are taking W1 is greater as compared to the W2. Voice आ रहा है अच्छी से? Please response anyone. You can unmute and tell me. Okay. So here what we are saying, when we are supposed to find the induced EMF, that will be in the form of magnetic flux and angular speed. We can take E equal to K phi W, and W we can calculate as 2 pi n upon 60, that n will be small n, or you can take directly W equal to 2 pi capital N. EA equal to KA phi W. I have given here which term we are calling what. We are aware about these equations because already we have seen here. So here, what we are saying, now we are having the equations for back EMF when we are using the DC machine as the DC generator. But what we are saying, torque is directly proportional with the armature current and it is directly proportional with the magnetic flux. And magnetic flux concept will come to the field winding, because when we will use the field winding, that is nothing but inductor. At that time, there will be generation of current, because when we are using the inductor, at that time it will store the energy in the form of magnetic flux. Phi is nothing but magnetic flux. So here we can take torque equal to K phi I. K is nothing but constant term. So here when we are calculating, we are deriving the numericals. These equations you guys will require. Again for the neta, E1 upon E2. It is nothing but you can take as